In this lesson, we're going to be graphing quadratic functions, and we're going to be graphing them in a standard form, where the standard form looks like ax squared plus bx plus c. So here's our quadratic in standard form. Our a value is 1, our b value is -4, and our c value is 3. So we're going to be graphing a quadratic, and we're going to be talking about these pieces of information that correspond to our graph. So in order to graph, we're going to need a couple pieces of information. And the first thing that we need to find is the vertex. Our vertex is going to be where the graph is centered around. To find the vertex, we have a little formula, a -b divided by 2a. And we're going to take the b value from our quadratic, our a value from our quadratic. We'll do this math. That'll find us our x value, and we'll plug that in to get our y value. So we have a -4 divided by 2 times 1. So that equals 4 divided by 2, which equals 2. Our y value is any time that you ever have an x value, you plug it in to the equation to get your y value. So we'll have 2 squared minus 4 times 2 plus 3. So 2 squared is 4 minus 8 plus 3. 4 minus 8 is -4 plus 3 equals -1. So our vertex is a coordinate of our x value is 2, our y value is -1. So that does a couple things for us. That's going to be the point that is either the top or the bottom of the graph, because a quadratic has a parabola shape to it, and this is the center of that graph. Everything else is going to be symmetrical around that. So right now we are sitting with a vertex of 2, -1, 2, -1. So our graph is either going to go up from here or down from here. Depends on the graph. So next part that we need is the pattern. So all quadratics have a pattern, and it's our change in our y's and our change in our x's. So our pattern for our quadratic is from the vertex, we're going to go up 1 over 1, up 3 over 1, up 5 over 1, up 7 over 1, and so on, with that pattern being applied. And our a value on our quadratic directly affects the y column, the change in our y's. So whatever the a is, we're going to multiply it to that column to affect our pattern. Our a value is 1, so it doesn't affect anything. So from this coordinate, we're going to change our y values up 1, and our x values are going to be over 1. And our graph is symmetrical, so we're going to go up 1, over 1, in each direction. And then we'll go up 3 over 1 in each direction. And then we can go up 5 over 1 in each direction. And that fits. We're not going to be able to graph any more points. We're not going to fit anymore. So that's our graph. So that's our quadratic. Now we can answer the rest of the questions. Axis of symmetry. So we have our vertex, and our axis of symmetry is basically this graph is perfectly symmetrical around this line. And that is known as our axis of symmetry. And that axis of symmetry has a vertical line to it, which means there is an x equals something equation. And that x equals, it passes through 2. Which also corresponds to the x value in our vertex. And that'll always be the case. So our axis of symmetry is always just going to be x equals the x value from our vertex. So that's our axis of symmetry. And it is an equation of a line, not just a value. So it's x equals 2. Max and min we're going to get from the graph as well. There's a highest point or a lowest point on this graph. There is a lowest point. So we have a minimum. So we have a minimum at And we're looking for either, depends on how you need to write it. It could be a coordinate or it could just be what is the lowest y value that exists on this graph. And the lowest y value is right there, a -1. Also matches the value in our vertex. So that value is always going to be either the maximum, the highest y value, or the lowest y value. It just depends on which direction your graph goes. And the direction your graph goes is totally dependent upon the a value. So they all kind of interconnect and mean something. So your axis of symmetry and your max and min is going to come from your vertex. So we have a maximum at y equals -1. All right, y-intercept. Our y-intercept could come right from the graph. So our y-intercept is this right here. So that is a coordinate of 0, 3. All right, another way we can do that is we don't have to graph it to actually know how to find your y-intercept. Your y-intercept actually comes from your equation. Your y-intercept is understanding the idea that every single y-intercept, your x value is 0. So you could plug in 0 into this equation. This would go away, this would go away. You'd be left with the 3. So that value at the end of the equation that doesn't have a variable, that's always going to be your y-intercept. So it's right there in the equation in standard form. Or you could graph it to find it. Also works just as well. But really what I look at it as is, I know what the y-intercept is going to be right from the start. I graph this, and that's kind of my check. Is that if I graphed this right, that do I hit the y-intercept like I'm supposed to? Yes, I do. So that's perfect. X-intercept also can come from the graph. We have x-intercepts at 1, 0, or we have it at 3, 0. Another way to look at your x-intercept is that every single time you talk about an x-intercept, the y value is going to be 0. Every single time. So, because on the x-axis the y value is 0. So you could take this equation, x squared minus 4x plus 3, and set it equal to 0, because that's the y value you'd be replacing, and solve your equation. And so we look to try and factor this. So this equation factors into x times x. What multiplies to 3 that adds to -4? -3 and -1. So we take each of our factors, set them equal to 0, because once we factor, we have the 0 product property. Set each factor equal to 0, and solve. So x equals 3, add 1, x equals 1. Those are our x values for our x-intercept. So we have a 3, 0, because if we plug 3 back into this equation, we get a y value of 0, or if you plug it into here, you get a y value of 0. And we have 1, 0, which also perfectly matches what we had on our graph. So every single time you've ever solved an equation, and if you set it equal to 0, you have found x-intercepts of if you graphed something. So you can look at the graph to find your x-intercepts, or you can solve it algebraically, find your x-intercepts. Your y-intercept is going to come right from the equation. Your max and min is always going to come right from your vertex. You just have to determine whether the graph is going up, whether the graph is going down. All right, so let's do one more. A little bit more complicated one. But all the math is going to be identical to what we just did there. So we have this one. So right away, I know that this is going to be my y-intercept. That'll be a nice check for us as we graph it. This is going to make the graph go down. That negative is going to vertically reflect our graph. So visually, our graph is going to look like this. That's what that's going to do. The 1/2 is actually going to widen our graph. So it's going to look something more like that. So the negative reflects it down. The 1/2 widens it, called vertically compresses the graph. So those are kind of a rough visual of what's happening. We need to find out our information. So we'll find our vertex first. So our vertex is going to be negative b divided by 2a. Our b value is negative 2, so it's a negative 2 divided by 2 times negative 1/2. So that's going to be a 2. Half of 2 is 1 times a negative is a negative. So that's going to equal a negative 2. Our y value is going to be a negative 1/2 times negative 2 squared minus 2 times negative 2 minus 3. So we plug in our x value into our original. Let's do the math, figure out what we get. So negative 2 squared is 4. Negative 2 times negative 2 is plus 4 minus 3. Half of 4 is 2. With the negative is a negative 2 plus 4 minus 3. Negative 2 plus 4 is 2. 2 minus 3 is negative 1. So our vertex is negative 2, negative 1. Okay, so we have that. Negative 2, negative 1. We have an axis of symmetry without even graphing it. It's going to be the vertical line right passing through the vertex. So that's going to be x equals negative 2. We just take the x value right from the vertex. Are we going to have a max or a min? Well, we know that the graph's going to go down because of the negative. So we're going to have a maximum on our graph. And our maximum I shouldn't have put the word at last time. It should have been a maximum of, our y value is negative 1. The highest y value that we're going to have, maximum of a y equals negative 1. That's our highest y value that we're going to have. Y-intercept, again, we already know what it is. It's a negative, a 0, negative 3. So that'll be a check as we graph it to make sure that it actually does what it's supposed to do. The x-intercept, I could set this equal to 0 and solve it. Let's see what the graph gives us. So the next part of information that we need, well, we have our vertex. So we have a negative 2, negative 1. But we need to know where to go. We have where we start. We need to know where to go, which is our pattern. Our pattern is change in y, change in x. Originally it's up 1 over 1, up 2, up 3 over 1, up 5 over 1, up 7 over 1, and so on. So let's see what our graph does. Our a value is a negative 1/2. So that means that every single one of these values is going to be multiplied by negative 1/2. So negative 1/2 of 1 is negative 1/2. This is negative 3/2. This is negative 5/2. This is negative 7/2. So I need to make a little bit more sense of this. This is negative 1.5. This is negative 2.5. This is negative 3.5. So we're going to go from there. So from our vertex, we are down 1/2 over 1. So down 1/2 over 1. And it's symmetrical, so we'll have it in both directions. Then we're down 3/2, which is really down 1.5. So we're down 1.5 over 1. And it's symmetrical, so down 1.5 over 1. Now this is also telling me we're heading in the right direction because it's matching our y-intercept. So that's good. And then we'll go down 2.5. So 1, 2.5 over 1. So 1, 2.5 over 1. And then we could go down 3.5. So that's 1, 2, 3.5 over 1. And it's symmetrical. So our graph looks like this. We have our axis of symmetry. Cutting the graph perfectly in half, symmetrical. We have our axis of symmetry at x equals negative 2. Our vertex at negative 2, negative 1. Our highest y value is a negative 1. Our y-intercept is at 0, negative 3, which came right from the equation. And our x-intercepts, we don't have any. So actually what would happen is if I try to set this equal to 0 and solve it, it may or may not be factorable. I may have to use the quadratic formula to try and solve it, and we would get a square root of a negative inside the quadratic, which means we have imaginaries. Imaginaries don't show up on this kind of a graph, so for this particular one, we don't have x-intercepts. So that takes care of it. So don't forget our pattern is going to be multiplied by whatever your a value is. This makes our graph go down. It widens our graph just a little bit. And those are all the pieces that we needed to graph it. So that was graphing quadratics in standard form.